Okay, in this video we're going to continue in our series of gas laws and gas law calculations. So here's an example problem that we're going to use the ideal gas law equation, PV equals nRT, to solve for the pressure of this fluorine gas when it is a certain mass sample, has a certain volume and temperature. Okay, but we're going to use the ideal gas law here to do so. So let's first read this problem. At negative 45 degrees Celsius, 71 grams of fluorine gas takes up 6,843 milliliters of space. What is the pressure of the gas in kilopascals? Okay, one of the first things I like to do when I read these problems is to write down and list the quantities that were given. Okay, so we have temperature at negative 45 degrees Celsius. We have a mass of 71 grams, and that is fluorine gas, which is F2. It's one of the diatomic elements. And we have a volume of 6,843 milliliters. And what we are to find is the pressure in kilopascals. And I find it a great advantage for students if when you read these questions you will list the variables out. So many times I've heard students say they don't know what to do, they don't know how to solve the problem. Well, they never get to the point of writing down what we know. We know these four things. We have an unknown pressure, a defined volume, mass, and we know what element it is, and we know our temperature of the gas. Okay, so we can always, in any chemistry problem, we can always write down what we know. There is never a time where just leaving the paper blank is appropriate. We can always do this. Now, let's move forward with these quantities that were given. First thing we need to do is the temperature needs to be changed to Kelvin, because when we work with gas laws we must work with Kelvin temperatures, because Kelvin has an absolute zero, all positive values, which will give us positive volumes and positive pressure and positive moles. Okay, so we negative 45 plus 273.15. Okay, that's the conversion over to Kelvin. So when we do that, and we're going to use appropriate sig figs here, it's going to be 228 Kelvin. Okay, that's going to be our temperature, 228 Kelvin. Now, we have a volume of 6,843 milliliters. We need to change that to liters, so that's 6.843 liters. Remember that 1 liter is equal to 1,000 milliliters. There's something else that we know, and that is R's. R is the universal gas constant. We know what that is because it's a constant. We're going to use 8.314 as our constant because we are determining the unknown pressure in terms of kilopascals. Okay. So here is our constant. So look how this problem is coming together. We have a T, we have a V, we have an R. Okay, we are looking for P, so we just need to get our N, which N is moles together. Okay, so we have 71 grams of fluorine gas. Now if we think back to previous calculations in our chemistry class, we know that 1 mole of fluorine is its molar mass. So we're going to take this 71 grams of fluorine gas and use our conversion factor, 1 mole of fluorine gas over its molar mass. Okay, and remember molar mass, we get that from our periodic table, and when we get the molar mass of fluorine, we find that it's 35.4527 grams per mole F. We have two of these because this is a diatomic element. So we're going to have 70.9054 grams per mole of F2. Okay, that's our molar mass. So 70.9054 grams. Okay, so when we divide these, well, it looks like we've got 1 mole, we might as well say. With 2 sig figs here, it'd be 1.0 moles of F2 gas. Okay. Now, see what we've done? We took what we know, the values given, and we did some simple metric conversions and a molar mass conversion, and we've got this problem practically solved. We can now say that P equals nRT over V. I rearranged the ideal gas law. Now let's put in our values. 1.0 mole. R is 8.314. Temperature is 228 Kelvin. And V is for volume, and that's 6.843 liters. Okay. Now notice my volume in liters. I did so because my R constant is calculated with liters. Our pressure is going to be determined in kilopascals. N is representative of moles. That's why I changed the 71 grams to moles. And temperature is in Kelvin. That's why I took the negative 45 Celsius and changed it into 228 Kelvin. Okay. So we solve this. Okay, so pressure is going to be in kilopascal units. So let's go. Well, 1 times 8.314, that doesn't change anything, times 228. And then we'll divide by 6.843. And we get 277 kilopascals. Okay? Now, we should use our significant figures. Okay, our 71 grams is limiting us to 2 sig figs, so this is going to get rounded up to 280 kilopascals, or if you wish to put it in scientific notation, 2.8 times 10 to the second kilopascals. Okay, so we always, in chemistry, we always write down what we know, look at the units and so forth if we need to convert something such as this milliliters to liters. Okay, so we always write down what we know, we write down the formula that we're using, and then we do substitute in those values and solve for the unknown.